Hello students. So today our topic would be vernier calipers. Okay. So we learn about vernier calipers, how this vernier calipers can be used to measure small lengths and accurately. So this is a device which we can use to measure the length of a small cylinders accurately up to 0.001 mm. And there are like you can measure the depth of the glass beaker. You can measure the diameter of the glass beaker. There are so many uses for this vernier calipers. So in this, I'm showing you the vernier calipers on the screen now. This vernier calipers have got some parts. This scale is called as our main scale. This is my main scale. And this smaller scale that you can see here, this is called as vernier scale. Okay. So there are two scales that are present here. So one is the main scale and the other one is our vernier scale. Then we have got jaws. These jaws are called as J1, J2, which are outside jaws. Okay. In this, you can place a cylinder to measure its length, or you can place any spherical bob, okay, to measure its diameter. So this jaws, in this jaws, you have to fix our instrument, whatever thing that you want to measure, and you can measure it accurately. Okay. Then we have got another two jaws at the above. Okay. So in that you can place a beaker. Okay. Like this. So that what happens? The beaker's width or diameter can be calculated. So they are called as J3, J4. These are called as inside jaws because these are placed inside the whatever thing that you are measuring. Okay. You are placing these jaws inside this thing of whatever you are measuring. These J1, J2 jaws you are placing outside the uh, whatever substance that you are measuring. So they are called as outside jaws. Then there is a rod which is called as depth measuring rod. This is called as depth measuring rod. What happens is if you keep a beaker like this, okay, any glass beaker like this, using this, you can measure the depth of the beaker. Okay, I hope you understood all the different parts of our vernier scale. Okay, next, let us move to uh, let us move to a topic called as least count. Okay, what is meant by least count? So least count is nothing but a smallest measurement that an instrument can measure accurately is called as least count. Okay, whatever it might be, the smallest measurement that an instrument can measure accurately is called as a least count. So in this, if I take a normal scale that we regularly use, in this what happened is this distance is 1 centimeter. This 1 centimeter is again further divided into 10 divisions. Okay. So now each division is 1 centimeter upon 10, which is nothing but 0.1 centimeter, which is equals to 1 millimeter. So how much length I can accurately measure with this scale is 1 millimeter. So I can give answers. If at all I give you a scale and if I ask you, what is the accurate measurement that you can give is you can give at the level of millimeters. Okay, this is called as least count. So next we'll see how a least count will be calculated in our what do you call vernier calipers. Okay, so we have to calculate our least count in the vernier calipers. Yes, so let us see this. Any instrument, if I give you, let us suppose we have two scales. One is 4 meter length. Okay. One is of 4 meter length and one is of 5 meter length. Okay. If I give you these two, if I give you like 4 meters separately and 5 meters separately. So with 4 meters, what is the least count that you can measure is nothing but 4 meters only you can measure because there are no divisions on this. Simple, I have given you a rod of 4 meters. That means you can measure up till 4 meters. That's the least count. Then I have given you another rod separately, which is measuring 5 meters. So what is the minimum length that you can measure with that rod is 5 meters because there are no markings on this. If there were markings somewhere here, you can measure 2.5 meters also. But the thing is, I have not marked anything. I have just given you, I have given you a rod of 5 meters. So the least count that you can measure with this rod is only 5 meters. Okay. I hope you understood this. Now, if I combine them both, okay, if I combine them both, what is the least count that you can measure? Now, when you place them side by side, this distance is 4 meters. Okay, and this distance is 5 meters, right? So there are two different measurements 4 meter and 5 meter. You can measure accurately the difference between them. That is 1 meter you can measure this. So the least count that you can measure with the combination of these two is this scale's length minus this scale's length. Yes. So length of the scale 1 minus length of scale 2. These measurements you can do. That is 5 minus 4. If I take any other one, like if I give you a 10-meter scale and let us suppose a 9.5 meter scale. Okay. What is the accurate measurement you can do? That is 10 minus 9.5, that is 0.5 meter is the accurate measurement that you can find out using the combination of these two scales. Now, using the same thing in vernier calipers also, we have got two scales. One is called as main scale, and over the top of it, we have placed a vernier scale. Okay, so there are two scales that are present in vernier calipers. One is called as main scale and one is called as vernier scale. What would be the least count that you can do in this? Least count would be if this is my main scale division and this is my vernier scale division, the difference between these two is what is my least count. So least count is nothing but one main scale division minus one vernier scale division. This is our least count. Okay. Have you understood how we can calculate least count? Least count is nothing but one main scale division minus one vernier scale division. So we know that main scale division is generally it is given in centimeter and these divisions are given which are given in millimeters. But the thing is, we don't know what is the distance or what is the measurement of this vernier scale. That will not be generally given. Okay, that we have to calculate. Then once we calculate how much is this vernier scale division, then the least count would be main scale division minus vernier scale division. I hope you understood. Now let us move to calculate this least count. Before that, we will be calculating this vernier scale division. Okay, chalo, let us calculate this vernier scale division, how to calculate. Okay, so what is this vernier scale division? Now, can I say in this whatever you have taken, how many main scale divisions are present? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is my 10th division. I hope you understood. There are 10 main scale divisions, and here we have vernier scale divisions 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, can I say 9 main scale divisions is equal to 10 vernier scale divisions? Okay, have you understood this point? 9 main scale divisions is equal to the length of 9 main scale divisions is equal to 10 vernier scale divisions. Now, can we find out if I say m main scale divisions? I am taking a general value. M main scale divisions is equals to n vernier scale divisions. Okay. Now, what is a vernier scale division from this? So vernier scale division would be equal to m by n main scale divisions. Okay, have you understood? What is a vernier scale division? It is equals to m by n main scale divisions. Now, what we do is we will take a general case, that is this thing. Let us take. Okay, we will take a case of this thing, particular case, not a general case. We'll take the case of this where 9 main scale divisions is equals to 10 vernier scale divisions, and let us calculate the least count of this whatever vernier calipers that has been given. Then we'll move to creating a formula for the any general vernier calipers. Okay, let me take, there is a vernier calipers where 9 main scale divisions is equals to 10 vernier scale divisions. From this, I understood that 1 vernier scale division is equals to 9 by 10 main scale divisions. Okay, right? Any doubt? Now, what is my least count? Main scale division minus vernier scale division. So how much is the main scale division? Let us keep it like this, MSD only. Vernier scale division is 9 by 10 MS into D. If my main scale division, as I have told you, Each division is 1 mm. Each division is 1 mm. Each division on main scale is 1 mm. So the this least count you are going to get as least count is equals to 1 millimeter minus 0.9 millimeter, which is how much? 1 minus 0, 1 minus 0.9, 1 minus 1 minus 0.9. This would be 0. Now 10 minus 1, that is, this is 0. So it is, how much is that? That would be 0.1 millimeter. 0.1 millimeter is my least count. 0.1 millimeter or 0.01 centimeter is the least count for such vernier caliper, where 9 main scale divisions is equals to 10 vernier scale divisions. Now let us give a general formula. M main scale divisions is equals to N vernier scale divisions. Okay. M main scale divisions is equals to N vernier scale divisions. So vernier scale division is equals to M by N into main scale divisions. Okay. Is it fine? Now, what is the least count? Main scale division minus vernier scale division. Main scale division is how much? MSD minus M by N into MST. Okay, M by N, MST, because vernier scale division is VST. Now, if I take MST common, that would be 1 minus M by N. So, whatever vernier calipers that you take, whatever main scale division is there, please put over here. Whatever number of divisions that are present, put over here. Whatever vernier scale divisions that are present, put over here. You are going to get least count of that vernier calipers. I hope you understood how we calculated the vernier calipers least count. Okay. Next, let us move. Now you understood, we have understood how a least count can be calculated. Next, we'll see a reading in the vernier calipers. Okay. Well, let us see reading in the vernier calipers. For that, let us see a simulation. Okay. So in this vernier calipers, you can see, yeah, you can see here. You can see here in the vernier calipers. Okay. This, let us suppose I have placed some rod or something like this. Okay. I hope you understood. Something I have placed like this. Okay. There is a main scale division that is shown up here. Okay. How much is that? 0.5. The main scale division is 0.5 centimeters. That means this rod is 0.5 centimeters, and on top of it there is also a little bit of small distance that is present that has been recorded in the vernier scale. So my total distance, total length of that will be equal to main scale reading plus vernier scale reading. Okay, main scale we have given me some reading, vernier scale also have given me some reading. So that would be main scale reading plus vernier scale reading. Main scale reading is 0.5 centimeter. Now I have to calculate this vernier scale reading. How much is this vernier scale reading? Now, please carefully see here what happens. Whenever I move, like, whenever I move this vernier scale, you can see now in this case, the main scale division and the vernier scale division are coinciding. So my vernier scale division, my vernier scale reading would be 0. Okay, I hope you understood this. In this case, my vernier scale reading is 0. Okay, now slowly I will move this. Okay, slowly what I'll do is I will move this. You can see one least count has been come. Okay, you can see the first, you can see here the first division of the vernier scale is coinciding with this main scale. Yes. So what happened? The movement that has been done is one least count. Okay. Now I will move it further. Okay. I will move it further. You can see now, if I take here, in the second division, you can see here, you can carefully, if you can observe here, I am present at the second division. Okay. Then you can see here the second division of the vernier scale is coinciding with the main scale. Okay. Have you understood? When I have moved second in this, the second division of the vernier scale is coinciding with the main scale. Okay. Now I will move it further. You can see now the third one, the third scale, you can see that when I move the third one, the third main scale division is coinciding with the third vernier scale division. Now, if I move it further, the fourth one, if I move it further, the fifth one, the sixth one, the seventh one, the eighth one, the ninth one, and finally the 10th one. As soon as the 10th one has come, now we have moved, the main scale division has moved to 0.6 millimeters. I hope you understood. So now how to calculate this? This whatever is present inside, how to calculate this? We have already calculated this in terms of least count. Yes, we have calculated this already in terms of least count. So each division, you can see this, each division is one least count. Each division is one least count. So how many least counts are present here? How many ever vernier scale divisions are present? So many least counts are present. So now, how will we find out at what division it is coinciding, at what division it is present? We have to simply see the main scale division and vernier scale division where it is coinciding. In this case, you can see here what happened. In this case, the main scale reading is 0.5. Okay. The main scale reading is 0.5. The main scale reading is 0.5 centimeter. Now we have to find out the vernier scale. So we have to see at which point it has coincided. How can you see that? This is the point. That means this distance I have to calculate. This is the distance I have to calculate. Okay. This distance I have to calculate. Now, how do I calculate that distance? We have to see this is 0, 1, 2, 3, 4, and fifth division of the vernier scale is coinciding with the main scale division. That means 5 least counts are present. Yes, that means how many least counts are present? 5 least counts are present. That is our vernier scale reading. So 5 least counts means 5 into 0.01 centimeter, which is the total length of the rod would be 0.5 plus 0.05, which is equals to 0.5 plus 0.05, which is 0.55 centimeter is the length of the rod. Okay. Now let us take another thing, another rod. Okay. Let me take a bigger thing. Okay. And we'll take one more case and we'll find out. Fine. So now what I have taken is, I have taken like this. Let us suppose we have taken something like this, and I want to put this thing also. Yes. Now you should do it. Okay. Let us do this. I'll remove all this. Yes. Now I have placed some kind of a bob or a ball in between. Okay. And I have asked you to find out what is the what do you call distance or length of this ball. Okay. Now we know that this is 1 mm, 2 mm, 3 mm, 4 mm. That is our main scale division is nearly 4 mm. Okay. Our main scale division is 4 mm. Okay. Fine. Next, now we have to, our main scale reading is 4 mm. Our main scale reading is how much? 4 mm. Now what we have to find out? We have to find out how much extra has been present. This extra we need to find out. This extra, okay? This is more than 4 mm. That extra we need to find out. So for that, I need to understand where my main scale and vernier scale are coinciding. Let us see. This is 0, 1, not coinciding, 2, not coinciding, 3 is coinciding. Have you seen this? 3 is coinciding. That means I am at the 3 least counts. That means plus vernier scale reading, which is 3 into least count. So that is 4 mm plus 3 into 0.01 centimeters or 0.1 mm. Okay, 0.1 mm, which is 4 mm plus 0.3 mm, which will give you 4.3 millimeters is your length of that whatever thing that you have taken. Hope you understood. This is called as our the way we measure this what we call vernier calipers. Okay. Now let us go back to our presentation. So now in this, you have understood how a reading of a vernier calipers can be done. Then we will understand about what is meant by errors in this. Okay. So there are few errors which is called as zero error. The zero mark on the main scale, if it does not coincide with the zero mark of the vernier scale, then the error is called as zero error. Okay, I'll show it to you. You can see here in this, the zero mark of the main scale is coinciding with the zero mark of the vernier scale. Okay, the zero mark of the main scale in this case is coinciding with the zero mark of the vernier scale. Okay, so you can see here the zero mark of the this thing is coinciding with the zero mark of the vernier scale. This is called as no zero error. No error is present. It is fine. Okay. This is a very good vernier calipers without any error. Now, I will add some error in this. Okay. I will add some error in this. I have added some positive 5 error. Okay. I have added some positive plus 5 error. You can see now the zero of the vernier calipers is not coinciding with the zero of the main scale. This is called as positive zero error. This is called as what? Positive zero error. Now, how do I subtract this? Simply positive zero errors must be subtracted from the value. So whatever reading you get, reading is what? Main scale reading plus vernier scale reading. Then out of that, you have to subtract your zero error if it is positive. Okay. So I hope you understood. This is the entire formula how to calculate the vernier scale readings. Okay. If the error is negative, okay, let us take negative error. So if the error is negative, you can see here the vernier calipers is now having a negative error. Okay. So the vernier caliper is before the main scale divisions. You can appreciate here. Yes, this is my zero of the main scale. Vernier calipers is present here. That means this much part the vernier calipers has come in front. So what we should do, that much part we have to add it back. So the reading would be main scale reading plus vernier scale reading. That is called as a negative error. So this is called as negative error. This negative error must be added to our, so zero error. This zero error, the negative zero error must be, negative zero error must be added. Okay. I hope you understood this. So this is how we will take readings from a vernier scale. Okay. So the entire formula is MSR plus VSR minus zero error. So once we brush up, what is MSR? MSR is nothing but a main scale reading. Okay. What is MSR? A main scale reading. Okay. What is VSR? VSR is nothing but it is vernier scale reading. How do we find out a vernier scale reading? Vernier scale reading can be found out by using least count into whatever coinciding division of vernier scale with the main scale. Okay. So that is how we find out vernier scale reading. Add those both, you are going to get the exact value or exact reading of that whatever substance that you are measuring. I hope you understood this. If you have any doubts, you can comment below. Thank you.